Okay, so good afternoon, everybody. Welcome to our webinar this afternoon on soil structure and earthworms. So this should be a bit of a masterclass, highlighting some of the key factors involved with how to assess your soil and why you would assess your soil to see what that would allow you to do in terms of savings and cost benefits. So just a bit of housekeeping here as we flick through it. Everybody is on mute throughout the webinar. That's kind of the way that these work. Obviously, we've had this will be the fifth webinar in the series, so everybody is unfortunately on mute. It's not a great platform for the collaboration, but we do have the question tab down at the bottom there. So please do use that for all your questions as you go, and I'll pick them up as we go through the webinar. If you could also put your basis and Enroso numbers in there. So there are basis and Enroso points. It's 2 points per session. So there is 6 points per day of webinar, so 12 in total. So these are quite lucrative. So if you pop your name and your basis number into the question tab at the bottom there, Christian and I will pick that up and we will submit them for your benefit. So today's session will last for an hour and a half. We're a little bit late in getting started, unfortunately, but we'll pick that back up. And the session will be recorded just so that it can be put out live on YouTube after, and we can email these to people as well if they wish to look back at them. We are on Twitter. We're having a bit of obviously the Strategic Farm Week here. So this webinar is part of the wider series. There's one more this evening at 7 o'clock. On the mold drainage and soil loosening, which will follow on nicely from what we're about to discuss today. And you know, you can register for these webinars live, which isn't too bad. So the format today, we've got David Aglen, who is our strategic farmer in Scotland. David's from Bulburnie Farms in Fife. So David will talk a little bit and introduce himself in a second. Then we've got Anne Bhogal from ADAS in West Yorkshire, currently at home, who will be joining us to take us through the slides. And then we've got Amanda Bennett, our soil specialist as well, so she'll be there to ask questions. So like I say, if you want to jump in at any point, put your questions in the box down there. I mean, I know they're not very intuitive, but if you pop it in, I'll pick it up and I can elaborate on it, and we'll jump in as we go. And anything we're not covering, please just suggest it in the box and we can take it from there. Okay, so today's question on the next slide. So it's learn how to assess your soil structure and earthworm numbers across the farm and how to use this information. So what would you like to know about the end of this session? It's really why are we doing this? What's the purpose of it? And hopefully David and I will manage to sort of ground truth that from Anne presenting how you would go about this and what you look for. And then David and I will maybe jump in as we go as to why you would do this and what David's learned from that and the possibilities that have come from that as David has as a strategic farmer. So we'll hand over to David now to do an introduction. Okay.
Good afternoon, everyone. As Chris has already mentioned, my name is David Aglen and I'm the farms manager here at Bulburnie Home Farms in Central Fife. We have been recently appointed as the strategic cereals farm for Scotland. The slide you're seeing now gives a brief rundown of the enterprises that we have on the farm. The areas are not very, not what we usually have this year. Like everyone else, we've had a battle with autumn sowing and we've had to make up a lot of ground with larger spring areas to get crops in the ground. We have the soils we have here are predominantly a sandy silt loam. We are very lucky in that respect as it gives us quite a lot of cropping options, and we are on the edge of the How of Fife, which is a large vegetable growing area up here. Next slide, please. Now, our future lies in our soils, how we treat our soils. This is us, and this was, I think, about 15 years ago. We have nice soils, but unfortunately they allow us to grow crops that then allow us to do this to the soils, which is not very good. This is a crop of carrots coming out sometime in the winter. Not a very pretty sight, I'm afraid. So if we move on to the next slide, please. what are we aiming to do with our strategic farm project here is ultimately it's all about the soils. Our future lies in how we treat them, as I've already said in the previous slide. We have crops that enable us to destroy them, but we wish to find ways to heal our soil in between some of these crops and perhaps even grow these high value crops to by doing less damage. So we carry out quite a lot of direct drilling here on the farm, and some of it's been successful, some of it unsuccessful. And what we want to do is try and find ways to improve the area that we can consistently and reliably direct drill and get good margins as a result. Cover cropping, we carry out quite a lot on the farm. Again, this is intending to improve our soils, improve the drainage, water infiltration rates, water holding capacity of the soil. It's a long-term process, this. We are limited by the species that we can grow as an autumn sowing cover crop, just due to the time of the year when we get our crops off the ground up here. So we need to investigate how we can increase the opportunities here to get more species in. We do grow some summer cover crops to graze with livestock, which is good, but getting a margin from that is a tricky exercise.
Yeah. David, just a quick question there, which is really quite interesting, which I know you've actually done quite a bit of. So Jonathan Bell popped in there. Within our 5-year rotation, we contract out land for potatoes, which I'm sure this is on everyone's tongue as well, and Anne's going to cover it later. But if he reverts to min-till, strip-till to try and improve soil structure, soil fauna and biology, will potatoes destroy all the good work in the previous 4 years?
This is one of the things. I've put this very similar question to many people, many learned individuals who know far more about soil than I do, in that how can we build our soils up to a state of health, say 10 out of 10 for the sake of argument, and how far down that scale does the health of that soil slide after a potato or a carrot or any other root crop? We just don't know. We can grow crops after these damaging vegetable crops. So obviously there's some life left in the soil. But a winter like this highlights that we've just had such a wet spell through this winter that fields after potatoes, that unless they were sown early on and the tatties happened to come out kind of early October, then it was a real battle, and indeed a lot of people just gave up. There was no point. Even soils that you might ordinarily expected to handle the punishment just couldn't deal with it. So we don't know is the answer. We have 3 years of cereals or other combinable crops and forage crops in between our potatoes and root crops and vegetables to try and extend the period where the soil can heal itself. But these are questions that we wish to try and find the answers to during the 6-year project. So that's a good question, Chris. So we're looking at integrating more livestock into the arable rotation. We want to build a resilient system around our regenerative farming principles, and ultimately we can hopefully overcome some of the problems that we experience with soil erosion, wind erosion of late. Some of the winds we had recently took a bit of soil away from some of the lighter land, and improve our fertility of the land so that we can improve the productivity and perhaps hopefully rely on less bought-in inputs, as it were. And essentially, as I say, we want to improve our soils, repair them, and allow them to work at their best and provide for us, because everything we do depends on the state of our soil. No matter how clever we think we are, if our soils aren't right, we're not going to have a productive business. Next slide, please. And as I say, finally, as I said repeatedly, our future lies in how we treat our soils. So we've now moved from a system where we were ploughing everything to direct drilling, min-till, non-inversion. Obviously, there's still some ploughing in there for some of the vegetable crops, although we are trying some now with strip-till this year for the first time, and I'm hopeful in the next few years we can succeed at that. And the picture on the right shows us a kale crop with cattle being outwintered I appreciate not everybody can do this, but we're lucky that we can. But I think we can. I think there are opportunities even on heavier soils to keep cattle or livestock of some sort on the rotation without actually doing any damage. So that's what we are. That's where we are, and that's what we're intending to look at, and how we really value our soils. But it's a tricky game, as we all know.
Perfect. Thanks very much, David. And hopefully, with Anne coming up just now, we can sort of explain a little bit of the how and the why. These soil structure and earthworms assessments are crucial to us. You get a year like last year with the potatoes and the carrots, and you got to get the crop out of the ground. We all accept that, but it's how do you come back from that? And it is difficult in the current climate. We need these crops in the rotation. I say need, but we're not at the stage yet where you can bypass that. I mean, everything has to work holistically. So, carrots and potatoes can be grown in these situations. I'm sure our potatoes team at AHDB are working on the no-till potatoes as we speak. So watch this space for that one. And we'll hand over to Anne. And no pressure there, Claire Hodge. But we'll hand over now to Anne Bhogal to take us through the soil structure and how to do this. Okay, thanks.
Okay, thanks everyone. Thank you for inviting me to join you on this webinar. I'm a soil scientist at ADAS, and I've been working with AHDB on their strategic farm program in England. And so I'm gonna, if we click to the next slide, please, this is just a bit of an outline of where we're gonna go over the next 30 minutes or so. So I'm first gonna talk about soil structure as an indicator of soil health, how we can assess it practically in the field and what things we can do to try and improve soil structure. Then we'll have a little bit of a break and some questions on that. And then I'll move on to looking at earthworms. Again, similar sort of structure, how we can practically assess them in the field and what we can do to try and improve earthworm populations. Then there'll be another little time of questions, and then I'm going to wrap it all up, bringing in Amanda Bennett, who heads up the AHDB BBRO Soil Biology and Health Programme. And in that programme, we're sort of bringing it all together, bringing the structure, the earthworms, alongside chemistry to look at a scorecard approach to soil health testing. And then we'll move back and have a bit of a discussion. So yes, thanks Fiona for moving that slide on. Yeah. So really the aim, as Chris has already said, is to provide guidance on how to assess soil structural condition and earthworms and interpret what you see. But at the outset, I thought I'd just bring David and Chris perhaps back into it, and we'll have a bit of a poll. We're going to do a little bit of survey of who we've got on the call and what you're currently doing. So Christian, if we can have the poll up, please, and the first question. So the first question I'd like you to answer, and you got the opportunity to click those yes or no, is: do you routinely assess soil structural condition? And while you're answering that, please, if you can have a go at answering that now, perhaps I can ask David that question, and perhaps you can talk us briefly through what you do in terms of soil structural assessment, David.
Yes, Anne, thanks very much. We have a fairly simple system of assessing our soil structure here. It's simple, a spade, basically. I just dig a hole and have a look. Where are the roots going to? Can I see any pan? How many have we got? Many earthworms there? Obviously, at this time of year when it's so dry, we're not finding many worms. Well, I did dig a hole yesterday in one field and found quite a lot of juveniles and youngsters, just obviously near the surface with that rain. And again, looking at the number of wormholes in the soil, that's a good indicator. One, that's drainage. Two, if the wormholes are there, then the worms are going to be there. They're just in a drier time. They've gone deeper into the soil profile. And I keep it very simple. 2 minutes and you can make an assessment and decide whether we've got to take some action or just accept what's there. So yeah, keep it simple.
That's great. Can we have the answers? Yes, please. That's great. Oh, so that's interesting. 62% say yes and 38% no. So that's quite encouraging, actually. I thought it might be the other way around, so that's really good. So thank you. Can we have the next question? If yes, do you, so 62% of you said yes. So do you use a formal method and actually score what you see? So David, you indicated that perhaps you don't formally score your soils, but perhaps if you could again answer yes or no, that would be really helpful. Thank you. So David, do you want to make any comment there?
I think again, it was quite lucky there we put as a yes, no answer and not actually gave the choices of what do you use to make the answer, whether it's a plough, a subsoiler, or whatever else. But I think most people would be scoring it in their mindset to, you know, the more you look, the more you find out. And, you know, as we've discussed before, we have the 3 gears of agronomy: first gear, second gear, and third gear. You know, if you're in third gear, you slow down to second, and if it's that bad, you drop into first, and then you get out with the spade. So, you know, interesting to see.
I also think, Chris, that if you you put a spade in the ground, as soon as you put your foot on that spade, you can feel whether the soil's right or wrong and warrants further investigation. And some fields, you just put the spade in and you don't even dig out a sod of earth. You just put it in, feels fine, and just walk away or go to the next bit. It can be as quick as that once you get used to doing it.
Yeah, so actually that sort of supports the majority of people didn't use a formal method. So if we just go to the final question, please, which is about counting earthworms. Do you count earthworms? So David, you indicated that you actually went out yesterday and had a little look to see what was there. So I don't know whether, again, while we're waiting for the scores to come in, whether you've got any comments there about actually recording the numbers of earthworms you see, or whether you're just having a little look-see.
I don't count them per se. There are suggestions of how many you ought to have in a spadeful, but I don't do that. What I do look is at the maturity of them. I think if you've got a lot of mature worms with saddles on them, and that's a good sign that they're living long enough to get to that mature stage, so they'll be going deeper in the soil, I think. It's when you open them up and you've just got juveniles and nothing but juveniles that you start to think, well, we must have done something, or we've maybe moved the soil too much and upset them a bit, possibly.
Yeah. Can we have the answers just to see what people said? So yeah, the majority, well, 50-50 actually. That's yeah. Interesting. Very interesting. So, yeah, that's great. Excellent. Okay, so now what I'll do is I'll just spend a bit of time talking about soil structure and how we might assess it and what it means. So first of all, my first slide is basically sort of background. What do we mean by soil structure? And it's all about the arrangement of soil particles into aggregates, the size of those aggregates, the spaces between those aggregates for water and air and roots to penetrate. But it's not only the sort of form, what we can see, that's important, it's also the stability of that structure. So its ability to withstand perturbations, odd seasons, difficult growing conditions, how it will bounce back from the season, like for example, we've just had the autumn and winter we've just had. And obviously one of the most important problems in some respects is compaction. That's where the soil particles get compressed, the pores are squashed, water and air can't get through. And as you can see from this survey that DEFRA did in 2012, 51% of farmers, when they assessed their soils, found that they had compaction within the top 30 centimetres of soil, and we're finding that widespread across the UK. So if we move on to the next slide, please, Fiona, that's great. So obviously it's really important to be able to assess whether we've got compaction present, where that compaction is, in order so that we can understand what we should be doing and where we should be intervening, and also whether the soil is in a condition suitable to actually track across and cultivate. And as as David alluded to, the best thing really, there's all sorts of different indicators and things that we can do back in the lab for looking at soil structure and soil structural stability. But the best thing is actually to get the spade out and actually dig. And as David said, just getting your spade in and how easy it is to get in can tell us a lot about what the soil is doing. But we can actually tell more about the overall health of a soil by just digging out a spit of soil. It's not just soil structure, we can look at colour and we can look at biology. So getting your spade out is essential. So there's these two formal methods. As I said, I asked about whether you use a formal method, and it's sometimes quite good to be able to score what you see so that you can then, when you go back later in the season, you can see how that score has perhaps changed over the years. So this first method that is widely used is the visual evaluation of soil structure, developed by SRUC. And this slide just shows, it's basically a two-sided scorecard you can download from SRUC's website. And the first side of it just shows you how to go about extracting the block of soil. And the other side, the second side, which I'll show in a minute, shows you how to go through breaking up the soil to see what you've got and scoring what you've got. So if we just flip to the next slide, please. Are we going there? So this next slide, which doesn't seem to be moving on my slide, so I don't know whether that's my internet, should just basically show me taking out a spit of soil. So what you do is all you need is a spade and a tray, basically. And you use your spades to, there we go.
There. I was just going to point out, just to have a little moment till Fiona resets that for everyone that's just come in there, down in this bottom corner here in the questions tab, if you do have any questions to come in there, please do ask them. And we're also using that just now for basis and facts and in ROSO numbers. So if you do have your basis, facts and ROSO, please pop them in that box and Christian and I will record them and put them in. So a couple of questions that came in, Anne, just till Fiona catches up.
Yeah.
What time of year do you start doing worm counts? Are they more dormant in cold weather?
Yeah, so both for soil structure, assessing soil structure, like in this picture here, and in for earthworm counts, you really want to do it when it's warm and moist. So this is the tricky thing when you come to assessing soils. There's an optimum time period to be able to do it. So you really want it in autumn or spring. Yes, if it's too cold, certainly those deep burrowing earthworms will be way below your spade. You'll be digging and digging and digging. So you want to really do it sort of spring when it's moist and autumn when it's moist and warm. Obviously, this last winter has been tricky. I know that when we've been out to assess them, there's been a very short time period. So the autumn was dry, 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 then sopping wet, almost too wet. And then the spring was wet, 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 and then dry, almost too dry. So it is a little bit hit and miss. But yeah.
I'll let you back to your presentation in a minute. Just how deep can worms actually go?
So yeah, the deep burrowers can be up to 2 meters down. So the deep dwelling earthworms will be right down there. And I will touch on this in a little while, but obviously you're only taking out the top cube of soil, and the majority of earthworms that you will find will be those topsoil worms. But I'll go into that in a minute. So perhaps we just click back to where we were previously. And this slide, yeah, you can go on to the next one, Fiona, that's fine, with me digging up a spit of soil. So basically, as I say, you just need a spade, you need a tray, and what you want to do is a spade's width and depth, basically 20 centimetres by 20 centimetres, cut round 3 sides, try and leave one side intact, lever that out, because what you want to do is look at that face of soil to see if you've got any layering. And it's really key that layering is good to try and identify. because it will tell us where there's different levels of compaction and where that is within the profile. And so the picture on the other side of the screen is a colleague of mine just breaking up. So what you do once you've got those layers and you've measured where they are, you start to break up the soil. So if we click to the next slide, Fiona, it will show you the scorecard and how you then rate and rank what you've seen. So basically, as you break up those different layers, what you're doing is to looking at the size and the appearance of the aggregates, how easy they are to crumble within your hand, how porous they are there roots running through the soil, are they rounded, are they angular? And we basically look from a score of 1 down to 5, 1 being very friable, nice and crumbly, and a 5 right at the bottom there being very angular, very blocky, large aggregates, really difficult to break down in your hand. And often you can see some mottling, some sort of bluey grey colours, which are really clear evidence that water, the air is not getting down there. So if we click through to the next slide, Fiona, basically what we're trying to do with this identifying layers is seeing what is the most limiting layer within our soil and where is that. So we've got 3 different pictures there. If you just click through to the animation, on the first one, you can just see that here with the limiting layer is below the top 5 centimetres. So the top 5 centimetres soil is nice and crumbly. We'd probably score that a 2. And below it, we've got a more angular blocky. So our limiting layer is sort of 5 to 20 centimetres. Whereas in the middle photograph, we've got it the other way around. Our compaction, our blocky scores are on the top 10 centimetres, and below that is a much friable layer. And then finally over on the far side is a nice crumbly, great structure. Look at those roots going through. There's no layering, so we score that as a whole block. And then there's just some photos that are going to come up on the bottom of the screen that just sort of show what sort of thing you're looking for when you break up the aggregates. So Fiona, if you can just click through. Yeah, so an SQ2 right there on the left-hand side, you can see it's a rounded aggregate. As we've broken it up, you can see the crumb structure, you can see roots coming through. And then as we go through an SQ3 and an SQ4, that SQ4, look how angular it is, and you can just see the little cracks and actual earthworm channels where the roots are just restricted to there. So they're just going down those channels. So yeah, Chris, you look poised for a question.
Yeah, just eager as usual. But what sort of scenarios do you find like an SQ4 in? We sort of, to figure this out, wheel tracks obviously bad. We get that, but where do you find these sorts of bits? Can you see it in the field, or is it a specific soil type, or how do you find that?
It can be quite widespread actually. We find that it's not necessarily restricted to your wheelings. Obviously, your wheelings will be compacted. You can find it wherever. In terms of identifying it across the field, if you've got a crop, you might see that the crop is a little bit behind, not established so well. It might be smaller, it might be yellower, so it's suggesting that the roots aren't getting through. So that would be a sort of indicator. Let's go and have a look at and dig and just see what is the problem there and where is the problem. But it can be widespread. Obviously, clay soils and wet clay soils tend to be more susceptible to compaction. But sandy soils equally, the surface compaction and capping can be a problem for sandy soils. So we do find it across all soil types.
Interesting. Thanks,
Anne. Okay. Right, should we click through to the next slide? So this is just to summarise what you get. So we're sort of saying a score of 1 to 2 is good. You don't need to do anything about that. That gets a green flag. 3 to 4, sort of moderate condition. We're probably saying you probably need to monitor that a bit more frequently and perhaps put in some more long-term improvements, try and build up your organic matter levels, for example. 4 to 5 is evidence that you've got poor soil structure and you might need some short-term improvements. You might need to think about subsoiling, that kind of thing. So if we move on to the next slide, just to quickly touch on an alternative method which you might have heard of is the visual soil assessment, so the VSA rather than the VESS. This has come from New Zealand, and there's 8 different properties that you're looking to score when you take out that same spit of soil. What you do is actually you first of all do a bit of an evaluation to see if you've got any layering and where, if there is a tillage pan, for example, but then you drop that block of soil up to 3 times on a hard surface, on that hard tray, and you look and see how the aggregates break up. And then you want to organise those aggregates into size classes. And then for each of these different properties, soil structure, consistence, porosity, colour, there's a pictorial guide within the guidance so that you can compare what you see according to 3 pictures, and then you score it, you multiply it by those factors that are in brackets, and you end up with a VSA score. And it's slightly different in that it's slightly confusing in that high score for a VSA means good compared to the VESS, where a high score means poor. So you do have to keep remembering these things. So 25 or more is good, less than 10 is poor. Again, Chris, you've got another question.
Just as a quick, does this change as to the planned crop? So for instance, if you were going into potatoes, would you be as fixated with you know, changes in the porosity, or you know, is the focus more if you're going into grass or into a spring crop or winter crop? Would that change with this?
Obviously, depending on when you've done it in relation to your cultivations, it will it will vary depending on what you've done. And we certainly, from the soil health scorecard point of view, we would say do it on a sort of rotational basis, or if you want to, you can use it to assess the effectiveness of your tillage techniques to see if they've worked. So you can do a before and after, but it's not necessarily crop specific. But obviously, the more tillage and implements you put in, the different things, impacts, it will have impacts, yes, on what you see.
You know, if we were sort of looking, you know, the barleys, traditionally we liken them to woolly sheep, you know, any excuse to roll over and die. Would that be the sort of one in the rotation? I know David's really struggled with the spring barley in a no-till situation, I should say. Sorry, Dave, I'm not insulting your prowess there. But you know, barley is notoriously hard to grow, and you know, combination drilling with fertilizers, put everything at it and just pray and hope for the best. But is this something that we would specifically look for to try and tailor a package after that, perhaps in a barley crop?
You could use it. You could use it before, you know, before you go in to do your barley, just to see what your soil structure is like. Obviously, you know, good soil structure, in order to get good early root development, is really important to be able to achieve. So yeah, that could be something where you would use it. So if we just click through to the next slide, it just shows the pictures that we, as I said, there's in this guide for VSA, there's 3 pictures for each category. So this is the one for soil structure and consistent. And as I say, you arrange your aggregates according to soil, the size of them. So over on the left-hand side is a good condition compared to the poor condition. It's really obvious, and it's really good pictorial guide. So if we just quickly move on to the next slide. So we have used these methods at the strategic farms in England, in the East and the West, to understand the baseline soil conditions as they Rob and Brian have set out on their journey on the strategic farm. We've assessed what their soils are like at the very beginning. So this is just a map of Brian's farm down in Suffolk. And what we did at the outset in autumn 2017, we used his mapping. So this is an EC map. Recognising that within a field you are likely to get variation in soil texture and soil properties, and it's important to be able to capture that variation so that when you go back to assess it again, you don't go to a different part of the field and then come to a conclusion that is completely wrong because you just sampled a different soil texture. So we found that for different fields, we had to split them up into different soil management zones and assess them differently. So for example, field 9 down in the bottom there, right at the bottom, we just had the one zone. We felt that it was a small enough field and the variability was such that we only had small pockets of different textures. So we assessed that as a whole. Whereas field 1, right over on the left-hand side, you can see A, B, C, D, 4 different zones we assessed. And in each zone, we did 3 VESS and 3 VSAs. Using the methods I've just shown. So we did that in autumn 2017 and again in 2020, just this spring just gone. So I'll just show you just some of the pictures. This is the VSA and then on the other side the VESS. So fortunately they agreed with each other. So about 14% of fields were considered to be in good condition, high 25, greater than 25 for VSA and 19% in good condition using the VESS, whereas 86% were in moderate condition, 81% having a firm or compact layer, SQ3 or 4. We didn't find any fields that had an SQ of 5 or were considered to be poor, which is good, but obviously Brian has got a few issues in terms of some compaction across his farm. And we found similar results for Rob's field and farms too. And this is something that we can be doing and it's looking to do up in Scotland at David's farm at the outset of his programme to see how these different management practices might influence that soil structure over the course of the strategic farm. So if we just move on to the next slide, just to quickly summarise before we have some questions, just what do we do if we've got soil structural problems? Obviously, in terms of alleviating it, it's getting your spade out, looking to see where the compaction is, and probably managing our cultivations accordingly. So might require getting a subsoil out. But really, we want to try and avoid it in the first place. So avoiding working soils when they're wet, obviously very difficult in this last autumn that we've just had. Thinking about the rotation and the choice of the crops that we grow on our fields, perhaps avoiding late harvested crops on soils that we know are particularly vulnerable. Obviously, low ground pressure tyres are really useful and really important to be able to minimise the level of compaction that we get. Enhancing our organic matter levels just to build resilience into the system. So where perhaps we're getting those moderate scores, the thing to do is to try and build up the organic matter. And things like controlled traffic farming, using the same tram lines to reduce the area of trafficking across the field is a good way of minimising the damage. So that's the end of the soil structure bits. If we just now open it up to some questions, I don't know how we're doing for time, so I'm just hoping someone's keeping me on track. So Chris, if there are any specific questions on soil structure and soil structural assessments, perhaps we can do that now.
Yeah, so I mean, one of the ones that came in there was, if we go back a slide just to your picture, and we go into the detail, thanks Fiona, I'm pointing there as well, great. The top right one, I mean, that's an all too familiar, you know, with drainage problems, all the rest of it. And, you know, one of the things we do when it's awful easy to say apply organic manures and whatnot, but you know, we do a little across the field. You know, we talk about application rates. Should we be focusing on these areas and say just spreading some organic matter, or, you know, how do you inject worms into that, if that makes sense?
Yeah, so I mean, we recognise the soil variability, and splitting your field up into management zones. If you've only got a few trailer loads of muck or whatever, it's important to understand, for example, where you've got low organic matter levels, where you have got soil structural problems. Actually, then you can, if you've done that sort of initial sort of survey, you can target where you're going to actually spread your muck or do your interventions. I think that is quite key.
We can bring a bit of the technology in with the zones and the soil scanning, which is the moisture, which will show these sorts of bits up. So we could target applications of organic manure and our focus there. And time depth, I mean, we've been through this a lot with Harry and whatnot as well. Sometimes in those conditions, obviously the tines can do a bit of damage. Now, that's sometimes quite hard to figure that out, if that makes sense. Like, you can think you're doing good, and part of the experience, those guys that do drainage, you get down to a metre deep. Well, generally the soil moisture doesn't change that much. How do you know, or how can you figure out, a spade depth is 6 or 8 inches, depending on how heavy you are to push it in, but how do you know if you've done damage at depth?
Well, actually, it's interesting you said that, and I didn't mention that. There is, SRUC have developed a sub-VESS protocol. So there is a similar sort of scoring system for actually going down into the subsoil, so below 30 centimetres. Obviously, that requires digging a bigger pit and going down, but you can actually obviously get below 30 centimetres and see what you're doing, what your structure's like. Obviously, trying to alleviate compaction below 40 centimetres depth is very difficult to do. You can't really get a bit of kit necessarily down there. And that's where it's probably more to do with the long-term improvement, trying to encourage roots to get down there, trying to encourage the biology to alleviate that deep set compaction, and obviously avoiding it in the
time scale on that. And so if we say, for instance, we had the bad patch in the field, and you think, right, wait a minute, we can just leave that and go and put some compost that we'd made from 7 o'clock session on Tuesday. So we made a compost. Now we focus on this wet bit here. We don't put a tine in it. If we just put the compost down, would that have enough life in it to allow the worms to burrow away and sort it out? And what would be the time scale to that?
Time scale is how long's a bit of string, really. Yeah, I mean, in terms of improving soils, that is just using a little bit of compost, bit of crop rooting, is going to take quite a while, and I wouldn't dare dream put a number on it, actually, if I'm honest. It is a long-term improvement, and obviously alongside that, it's trying to make sure you don't do additional damage. So making sure that you avoid, you only do the cultivations that are necessary. You do them at a suitable time when the conditions of the soil are such that they can take it, as it were.
Perfect. Thank you, Anne.
Great. Okay, so we move on to have to think about specifically about earthworms. Oh, as Amanda.
Yes, sorry. I wasn't just before you head on to the worm section. I just wanted to flag up another resource as well. That is the Think Soils Guide, which is by the Environment Agency. It can be accessed on the AHDB Great Soils website, and it's a really brilliant visual guide to look at soil issues, and actually there are great examples in a lot of different soil types with different production systems. So the VESS card itself obviously has the pictures for those scoring categories, but sometimes it's good to have a range of different images to compare and look at. So I think the Think Soils Guide is a really a good resource as well that we can bring into the picture for that. Thank you.
Thanks, Amanda. Yeah, that's great. Okay, so shall we move on to earthworms? So I'm probably telling you things you already know. Benefits of a healthy earthworm population. Well, obviously, why do we want earthworms in the soil? They're really important in terms of incorporating organic matter. So organic matter, we've established, is really important for building resilience into the soil. But actually, if we put a load on the surface, if we're trying to minimise our tillage, how are we going to get it mixed within the soil? And earthworms are really important there, in not only mixing that organic matter, but actually helping to break it down and release nutrients. But the deep burrows in particular are fantastic at improving soil structure, in creating aeration and drainage channels, which obviously water, air and roots can then explore and get down deep. If you saw some of the pictures earlier, you saw that actually where we have structural problems, it's those biopores that are really important for roots to be able to get down into. And often you can see, if you dig a big profile, you can see dark streaks going down deep into the soil, which is where the earthworms have basically pulled organic matter, and it's the lining of their burrows going down, incorporating organic matter to some depth. But obviously, we mustn't forget that actually they're a really important food source for birds. So encouraging biodiversity back onto the farm and giving those birds something to eat is really important. And as earthworms are sensitive to pH, they're sensitive to waterlogging, they're sensitive to compaction and tillage, and the way in which we manage organic matter, they do provide an overall indicator of soil health and an indicator of how the different practices we might be employing are behaving and are influencing soils. So if we click to the next slide, as already alluded to, we've got a number of different types of earthworms in soil. So it's not only about how many we've got, it's looking at what species we've got. And although there are about 27 different species of earthworms in UK soils, and I don't know how to identify all of them, I have to admit, it's nice that they can be grouped into 3 key categories. So it makes it quite simple to understand what we've got. So those are, we call them ecotypes. So here, this is the surface worms, the epigeic worms. These are litter dwelling worms. They live right at the top, feeding on crop residues. They're not very good at burrowing. So they actually they're the ones that feed the birds in some respects. They tend to be short-lived. Their life cycle is very short. They turn over very quickly. And we identify them as being small, sort of less than 8 centimetres, bright red, reddish brown worms, and they're particularly rapid at moving around, probably because they want to try and escape from those birds. If we then move on to the next category, the topsoil worms, the endogeic worms, these are probably the most common worms you'll find in an agricultural soil. They can be distinguished from the epigeic because they tend to be quite pale. They're pink, they're green, they're grey, or even blue, up to about 10 centimetres long. And they often actually curl up. If you put them in your hand, they curl up. They don't move very particularly quickly. And they live for a little bit longer. And the ones that live in the topsoil, and they make horizontal burrows. So these are particularly important for that soil mixing, sticking particles together, aggregating the soils, and basically releasing nutrients from the organic matter. And finally, those deep burrowers, the big beasts of the earthworm community, the anisic earthworms. These are large, probably what I would call the classic earthworm. They're black-headed or red-headed. And these are the ones that make those deep vertical burrows, and as I say, up to almost 2 meters in depth. They live for a lot longer, so they have slow reproduction rates, and they feed on the soil surface. So they basically pull crop residues. You can often find them actually, if you haven't been able to dig them out in your soil pit, you can find them by looking for the middens, the sort of casts at the top of the surface. It's almost like a refrigerator. They pull the piles of leaves and make a little store cupboard at the top of their burrows, and you can often look and count for them. But they are the ones that are really important for aeration infiltration. Chris, you're poised.
Just poised. Just a really slapstick comment that we get from I call them ploughman. It's not a brand at all, but and actually my 4-year-old brought it up the last day. If you cut a worm in half, so say these guys did get injured, do they still keep going, or is that the end of them?
Do you know, I think that is pretty much the end of them. You do tend to see them wriggling around when you cut them in half. Yeah, tillage is not good. It does tend to destroy them. I mean, for the deep burrowers, the tillage effect is actually the loss of their channels there, because they're permanent. It's cutting up those rather than necessarily cutting up the worm itself. Because if they're below the level of tillage, they can obviously avoid it, but it's the destruction of their burrows that's particularly key. No, but chopping them up is not good. They don't like it. We
can't double our numbers just by by cultivation.
No. And when you're counting them, you can't count two halves as a whole, as separate. You have to fit them together.
Yeah. So we need to feed our worms, not cultivate our way to
not cultivate them to double your numbers. No. Okay, shall we move on to the next slide? So how do we assess them? As I say, this is really much linked to the soil structure assessment, and it's great that you can actually link the two measurements together. So autumn and spring, warm and wet, not too cold. And we can use, as I say, the same block of soil that we've done for our VESS. So 3 or 5 pits per management zone. And what you do is as you are breaking up your soil to look at the soil structure, the size and shape of those aggregates, you basically pull out your earthworms and put them into a little pot by your tray, so that at the end of that assessment, you can then count out how many you've got and tip them back into the hole. So we say do that for about 5 minutes. You can spend hours breaking, particularly on heavy soils, breaking them apart, and you keep going smaller and smaller and smaller. You can see little juveniles. But actually, if we try to sort of standardize the length of time so that we can then compare to some standard values. And in the VSA guidance and in the scorecard, we're using this approach as in this table down here. So number per spadeful that you found in 5 minutes. For arable soils, less than 4 is considered to be depleted. Obviously in grassland, you would expect there to be more earthworms, so we're saying less than 15. And for a good population, an active population, it's greater than 8 for arable or 30 for grassland. So if we move on to the next slide.
Just had a quick question there, just while we're on it, and I mean, one of the things that's all too common that we seem to get quite a lot of discussion on, when we talk about ploughing down, when we incorporate straw to a depth and we seem to get this, and it comes back up next year and it's that sort of black direction, it obviously hasn't fed the worms. But is there, if I suppose I'm asking, what is the best way? What's the sort of worm food? I mean, you're expecting higher numbers in grass, so does it say actually, well, hang on a minute here, grass is the best way of feeding our worms? Is that what we should be looking at in our rotation? Or should we be putting the straw down there? Should we leave the straw on the surface? There's these sorts of things. Do the worms, if you get that anaerobic layer, do the worms go through it? What do we do?
Yeah, so obviously grass is good for worms. Grass is good for soil organic matter. Having grass in your rotation is a really good way to improve the overall health of the soil. Leaving the soil, the straw on the surface is probably preferable, because the cultivations will basically destroy the earthworm channels, as I've just said, and chop up all your worms. So actually, it's probably best to try and minimise your cultivations and keep the straw on the surface. Is my answer there. But as I say, once we can just count the total number we've got, and that gives us a good indication of the sort of overall health of our soil. But actually, if we want to dig a bit further, it's quite nice to be able to split up what we see according to those different categories of earthworm type. So to take it one step further, you could then look in your pot, once you've counted your total, split the earthworms into adults and juveniles. And so that's really simple, in that an adult will have that saddle. So if you look at the pictures on the right hand, you can see that paler area, that band around towards one end of the earthworm. That shows that it's an adult that you're looking at. So sort them out, count your juveniles. You'll probably find that about 75% of your sample will be juvenile, which is absolutely normal. The juveniles can then be returned to the pits, and then you can look at your adults in more detail and categorize them into those 3 different categories. In very simple terms, the small red fast worms, the intermediate pale greenish worms, and the really large worms with the dark heads. And what we're really looking for is actually a balanced sort of population. We want examples, we want representation of all three categories in our field, really. So ideally, about 70% of the pits that we sample should contain all three groups. And as outlined at the beginning and at the end, you have the opportunity, there's some really good guidance online and on the AHDB website to help you do that, including an assessment sheet that you can fill in as you go along. So if you move to the next slide, just to give an example of how we've been doing that, as I say, alongside the soil structural basement line assessments we've done at the Strategic Farms, we've done an earthworm count. So these are the results for the east. So Brian Barker's fields, 8 of his fields. We've got the numbers we counted in 2017, and then again the numbers we counted in 2020, coloured up according to those scorecard thresholds that I showed earlier. And I suppose that the thing to look at is sort of the colouring, and really for the majority of the fields, we saw no change or improvement, all bar one of the fields. So for example, Barnfield at the very top has actually seen a really good improvement, a doubling in earthworm numbers. So just to put a bit of context there, so when we sampled in the winter wheat, that winter wheat had followed grass actually, but the grass had been quite intensively cultivated. So the earthworm numbers were particularly, were lower, whereas the spring beans, all subsequent cropping between 2017 and 2020 were established using minimum tillage techniques, and the spring beans actually followed a cover crop. So we've sort of got a reduced tillage and a cover crop in there, helping to boost the earthworm numbers in that particular field. Likewise in Kells, where we had 3, a red flag there, down third one down, stubble bare soil, that was basically bare ploughed soil, whereas subsequent crops were all established using minimum tillage. So in the winter wheat, we've seen a nice doubling, more than almost, yeah, doubling of the earthworms. The only issue was in Wally's field, and I hold my hand up, I'm not quite sure what's gone on there. So second from bottom, 8 down to 3. All I can think of is that field is a slightly lighter textured soil, and when we went in spring, this just gone, as I said, it's really difficult trying to pick your time. We went when it was getting a little bit dry probably, and so those earthworms were probably hiding down a bit deeper where it was a bit moister, and we didn't pick them necessarily up. So that's the only thing I can think of there at the moment. So if we just click through to the next slide. So in terms of managing, it's all about, as we've discussed, feeding the soil through what we're growing and through what we're returning to the soil in terms of organic matter. Only moving the soil when we need to, and keeping a diversity of plants in space and time. And that's it on the earthworms bit. So yeah, Chris, you've come up at a good time for questions.
Good time for questions. So if we just go back to that previous slide there, it's got quite a few nice pictures in there that we sort of want to talk to. And David, you'd be a good one to help. So one of the things we're looking to define here, David Rhodes was asking, what do you mean by min-till? I mean, you know, we've almost got max till, ploughing, min-till. So in your eyes, Anne, and this is, you know, from your research, what is min-till?
Well, at the moment, I'm probably saying anything that's non-inversion, but you know, so avoid the plough, yeah, and obviously reduce the depth of our cultivation. So I think a scuffling of the surface, or maybe a strip tillage type thing approach, where you've got areas of undisturbed soil and disturbed soil is probably beneficial, but obviously definitely trying to avoid the plough if we can. But yeah, David, it'd be interesting to hear what your comments there in terms of cultivation depth.
I think it's the min till. It's, you know, min is minimum, and it's as shallow as possible. I think we get very confused with min-till when we're putting cultivated tines 8-10 inches into the ground. I mean, that's just non-inversion ploughing effectively in my eyes. Yes, there's maybe a place for it, and there is a place for it in times, but no, it's as shallow as possible. Really.
Perfect. A couple of interesting questions. So when we are assessing it, we'll move on to the slurries and organic manures in a second, but Gordon Caldwell there, I've recently seen worms curled into a little ball, and I've seen that, you know, in my past career as well. What causes that? And I mean, is that sort of cultivation, or is something applied to soil? And is there things that worms don't like? You know, I mean, too much alcohol is bad for you, but it doesn't stop us, does it? But is that sort of scenario, does that apply to worms?
To be honest with you, I'm not sure 100% why they would curl into a ball. It could be that the soil's too dry. Amanda's coming in there, so I'm hoping she might help me out. There are worms that do actually curl up naturally. Those endogeic worms do curl, and it probably is a stress response. I know that when I put an earthworm on my hand, it's curled up immediately, and it probably doesn't like being on my hand, so it could be a stress response. Amanda?
Yeah, sorry, I was just going to say, so earthworms, when they do get, because obviously they need moisture around them, so when it does get too dry, they kind of go into an aestivation type state, a bit like snails, or, you know, anything that when it gets too dry, they kind of go in on themselves. So yeah, it's a bit like, not quite hibernation, but aestivation, so when it gets too dry. So you might find them curled up just to protect themselves in those particular conditions.
And then if we go on the opposite of that, if it's you know, if it's flooded, for instance, or too wet, can they swim, or do they float away, or do they just die?
Possibly just drown.
Yeah, they do. They drown.
If it's too wet, so you know,
don't like it.
No, yeah, everyone's got a happy medium.
Yeah. So if we move on to, oh, sorry.
I was just going to say that we tend to find the areas of the farm that flood in the winter. It's the flooding's caused by heavy rain and just a sealing of the surface cap. And actually, if you dig down through the cap, you'll find dry ground underneath. And if you keep going, you'll find the worms there quite happily. It depends where the pan that's causing the flooding occurs.
Yeah. Now, one of the things we're going to launch into there, I mean, we've got a nice picture there of the tractor applying organic manure, and unfortunately, some of the rule books do say that you have to incorporate within 12 hours, and incorporate can be deemed however you wish. But you know, in my past as well, and present, I mean, when you apply a liquid slurry, you know, and these digestates, I mean, we're talking 40 tons per hectare applied here, or you know, 40 cubes as well. We seem to get, you know, you get the seagulls behind it, and you get the worm. Well, I'm assuming the worms come up, but you know, is that what's happening, or are we flooding them to the surface, or is the pig slurry scenario? You know, historically we've been broadcasting it, but we are starting to now inject it, which is classed as incorporation. What's happening there? Is it, you know, if you could to both of you really.
So obviously, as we've alluded to, earthworms don't like waterlogging. So obviously, if they're getting too much slurry into their earthworm channels, they'll probably end up popping up and trying to breathe. And obviously, if the ammonium concentration is a little bit high, some of the digestates can be a little bit high in ammonium, so the ammonia released from that can be a problem. So they're probably trying to escape that to a certain extent. We have found, though, they bounce back quite quickly after something like that, and they can escape. They can obviously move away from the issue, as it were. But that is probably what is happening, yeah.
And by that, they're coming to the surface to try and escape it, going down the way. Is that what we're sort of thinking?
Either way. If they've got a load of slurry going down their earthworm channel, they might just try and let's get some air, something like that. But obviously, with an organic material coming out, if it's come off a heap, a solid, you've probably got earthworms in that heap. So you're actually probably applying earthworms with your solid manure. And the seagulls are following your tractor, not because they're eating the earthworms that are coming up from they're eating the earthworms that have come from that manure heap, as it were. So you've got both sort of happening.
Yeah, either way, shoot the birds, or probably not meant to say that, but yeah, you know,
No.
try and keep the birds off the ground would be the easiest way to do that. The birds are the enemy there, try and keep the worms. Yeah, no, that's perfect. David, you'll see a bit of that with the, you know, you're working with your organics and your composting as well.
Yeah, worms in the dung heaps. We're just trying to start composting now, so see how that goes. But the incorporation thing is the bit that concerns me. I always think the best place to leave the dung from a natural and biological point of view is sitting on the surface and let the worms deal with it, let the biology deal with it. Unfortunately, the rules don't always allow that.
And when we're composting, Anne and Amanda, what's the sort of life cycle of a worm? How quickly can we generate them, and where do they actually come from? You know, ask a kiddie question, don't you?
That's a very tricky one to answer, Chris. I think one of the key things is to remember these are living organisms that have, you know, some of them have very long reproductive cycles. So if those worms aren't in your soil to start with, you can't expect them to materialize from nowhere. If they have to travel in from elsewhere, from a hedgerow or a field, you know, it's going to take a long time for them to get to the middle of the field, for example. So as Anne was saying about sometimes the solid organic material that you put on may have those litter-dwelling earthworms in them, or perhaps some eggs from other earthworms. You know, they will slowly be reintroduced into a field, but you can't expect 1 year to find none and then the next year, oh, thousands of them. I think there's, you know, a long-term mindset is good.
So yeah, exactly. So there's one of these things we were discussing quite a bit on Tuesday's call, that actually, you know, taking the straw off, for instance, which we're saying is not particularly amazing worm food, and actually looking for a more bulky organic manure that may contain worms would actually regenerate a soil quicker than, say, just chopping the straw and subsoil and whatnot else. So we could actually import worms, is kind of what I'm reading for this. We actually need to import worms to regenerate soils.
Well, you need to import them from somewhere, whether it's from the hedgerows they're coming in, or whether it's, you know, it's from your organic materials. If you, as Amanda said, if you haven't got them there to begin with, they've got to come from somewhere. But there will be a popular, except on a probably really sandy soils. Sandy soils are obviously the tricky ones, because earthworms don't like sandy soils. Sandy, low organic matter soil. So you've got to probably bring it in. I mean, I would say that straw and leaving straw on the surface is good earthworm food. There's been quite a lot of work. Jackie Stroud's done quite a bit of work showing that they do quite like straw and farmyard manure. And a highly composted material is not necessarily good earthworm food. Yeah.
Perfect. Okay, we'll move on at that. Thanks.
Yeah. Okay. So I just wanted to spend the last sort of 5 minutes or so of sort of formal content, just showing how we're bringing together the soil structural assessments and the earthworm assessments into a sort of more integrated approach to checking the health of your soil. Not every year, perhaps on a rotational basis. And there's a lot of interest in how we assess soil health. There's lots of different indicators out there. And really, as part of the Soil Biology and Health Partnership Programme, we wanted to try and come up with a suite of indicators that were practical, easy to use, and easy to interpret, that have an interpretation framework that can be used to then guide management decisions. And so we're sort of adopting an approach. It's sort of like an NHS health check, that if you get above a certain age, you are asked every 5 years to go into the doctor's surgery to have a health check. And what they'll do is they'll do some physical assessments of your blood pressure and weight, for example, and then they will take a blood sample and send it off for chemistry. So it's the same sort of approach for soil, sort of every 4 or 5 years, going in, doing some soil physical assessments, but also looking at the chemistry and the biology. So within the partnership, we've reviewed different candidates of those different key categories: the physical, the chemical, the biological. So on the physical side, out of 17 candidates, we picked 3 just to keep it nice and simple, focusing at the outset on the VESS, which I've just described, because that's got a nice interpretation framework available. It's practical and easy to use in the field, but also thinking about penetration resistance and bulk density as potential indicators. Then on the chemistry side, a sample sent off to the lab for pH, routine nutrients and organic matter content. And then on the biological side, linking with the VESS assessment, counting those earthworms. But also then we're also exploring how we might assess the microbial side of the soil health, looking at respiration rates and microbial biomass. So at the moment, the scorecard that we're working with has those indicators that I've highlighted in bold. So if we flip to the next slide, please. In terms of benchmarking and interpretation, which is really key, there's no point measuring something if you don't understand or we haven't got anything in our sort of toolbox to be able to understand what we see and therefore guide our management. So for pH, routine nutrients, we're just using RB209 guidance in terms of the soil indices. The VESS is looking at that limiting layer score, where soil structure is poorest within that spit of soil. For soil organic matter, we're using a slightly different approach. We're comparing what we see with a loss and ignition measurement to what is typical for that soil type and that climatic region. Just broadly separating soils into light, medium, and heavy, with heavy soils expected to have higher organic matter contents. And then the climatic region, dry, medium and high rainfall areas. So wetter areas expected to have higher organic matter levels. And then the earthworms, you've seen the guidance that we're using in terms of numbers, total numbers, adults and juveniles per pit. And then we've got this traffic light system of no action needed, a green traffic light. We don't need to do anything, just carry on as normal and assess it again in your 5 years' time. An amber is perhaps monitor more frequently and think about some long-term changes that you might want to put into place. And a red flag would be you need to get out and investigate again. It might not be that there's a problem, it might be that your soil is just not typical of the region, but everything is fine. But equally, it might be that you found that actually there is some severe compaction. There are no earthworms, for example, and you could perhaps think about how you might want to address that. So if we move on to the next slide, this is just showing, if you just click the, yeah, that's brilliant, thank you. Obviously Rob there at Strategic Farm West, just to show what we've done there. Again, at the outset, so this is last spring, 2019, we used Rob's soil maps to understand how soils varied within individual fields so that we could split them up into management zones so that we don't, in 3 or 4 years' time, when we go back to sample a completely different area of the field and think, oh, okay, we've got an improvement here, but actually it's because we've gone to a different texture. So, for example, this field 25, we split into 3 zones. And then within each zone, we pick a representative area, so avoiding headlands, avoiding tram lines, avoiding any obvious depressions, that kind of thing. And we GPS it so that we can go back there in several years' time. And then within about a 10-metre radius, we take those 3 VESS pits, 3 earthworm counts, and then a topsoil sample to send off to the lab. So if we move to the next slide, this is the scorecard that we got for that field that was going into spring barley. So as you can see, the texture was right. We have those 3 zones of increasing soil clay content. And interestingly, the thresholds for the organic matter were slightly different because of those. We went from a medium to a heavy soil across the field. So on the medium soil, we have what we consider to be average organic matter levels, so absolutely fine. And on the heavier textured soils, actually, we had a lower organic matter contents and below average for what we would expect for that soil type near Leamington Spa. So pH and basically that's a reflection of his underlying geology and what he's got to work with. On the nutrient side, it's picked up and flagged up phosphorus as perhaps being a little bit low in that middle zone, index 1. But the key thing that jumps out is the VESS scores and his earthworm numbers. So seeing particularly on the heavy soil with that lower organic matter content, he's got evidence of compaction, a score of 4 for his VESS, and he's got very few earthworms. So in fact, actually, a problem with Rob's farm and fields are earthworm numbers across a number of his fields and his soil structure scores. So if we just move on, yeah, that's just highlighting the issue. So that's it really. And I just wanted to, I'll just flag up, and there are some handouts, I think, attached to the webinar, linking through some of this guidance that can be used.
Handout bit is just down here. I should have said at the start, there are 5 handouts there.
That's right.
Principles of soil management. So they are there, and there's more on the AHDB website as well. Perfect. Thank you very much for that.
Okay, so that's me. Yeah, so we can do some questions now. That'd be great.
Yeah, we've a bit of time. There's Amanda.
Yeah, sorry. Can I just ask Anne to go back a slide to the scorecard, just as a point of clarification? So where you've got the soil organic matter, and you've got the 5, the 4.7 and the 4.4. So we're not looking here necessarily at just the numerical value as being the threshold. It's because we are in different soil types. So you've said that because of the soil texture and the climatic region, we have these different thresholds for the soil organic matter. So I just wanted to be clear on that, so if field 2 had got to 4.9, it might not have moved into the green category. And in fact, because it's in a different band for interpretation, if it had been 5.2, it might still have been color-coded amber. I'm not sure if that's making sense, but just to say that we have these different boundaries for different soil types. Yeah,
that's correct.
What we're seeing here, Anne and guys, is this sort of similar? You know, we have a lot of people doing yen now to try and help quantify the on-farm trials in their own circumstance. You know, crop trials are great, not starting that political subject just now, but on your own farm, is this sort of similar to what we get back from the yen? Is that the way to do this, is actually to look at entering the yen sort of side of it to get some of this information back to you?
So as far as I'm aware, the yen will give you an underlying soil. It will probably give you those first soil organic matter, pH and extractable nutrients. You don't do the VESS and the earthworms. That's separate, but obviously as an entrant you can do that yourself now, especially as you've just heard how to do it from this slide. So yes, you would get those initial soil chemistry done as part of yen.
Yeah. Perfect. Now, one of the other things which David will, and Amanda as well, we've got you guys on here on the soil side, and then we sort of had the plant nutrition on Tuesday there. Now, the two are obviously very highly linked. So if we get into the greens here, everything perfect, thumbs up, good to go. So what does that allow us to do? Is that different crops? Is that better plant health? Does that mean, do we stop applying things? Well, you never stop, do you? But, it'd be interesting to see when we do kick off with Paul Barney, and David's been doing yen as well, but how does this help us as farmers actually engage, and what's the next step from here? I'll put that out for everyone.
Yeah, so if all that's green, if Rob, all that was green, I would say to Rob, what you're doing is great. Is in line with what we're doing. It's suggesting that in the soil there aren't necessarily any issues that are coming up. And I would almost say don't stop, because obviously if you stop what you're doing, then you potentially start to cause problems. So for example, if you are routinely applying some muck don't stop, keep that as your routine, because you'll disturb the sort of equilibrium that you're starting to build up within your soil. But then I would say, let's have a look at the crop. You know, it is what the crop, how the crop performs, agreeing with what the soil scorecard is saying, and that's where it starts to get interesting, because if it isn't, then you sort of might want to drill further and try and understand, maybe it's spatial variability, or is it the season, or is there disease pressure, that kind of thing. There's other things that then start to come in to play. Would you agree, Amanda?
Yeah, I'm nodding along here. I think if you get the soil in as good a condition as possible, you know, with no major issues, that gives the crop the best chance it's going to have. And equally, to be as resilient as possible to things like foliar diseases. You know, if you've got a really good healthy root system and then the crop is strong, you know, that's going to be able to be a bit more resistant all round. If you've got soil-borne pathogens, for example, but your soil condition is really good, perhaps that is encouraging a good beneficial microbial community below ground that will be able to suppress any effects of soil-borne pathogens. So it's just getting that holistic view around, you know, say the half of the plant is below ground. So if we can get that environment where the half of the plant is living in a good as condition as possible, then obviously it's going to have hopefully the benefits above ground. But coming back to that point, as part of what we're doing within the Soil Biology and Soil Health Research Partnership, and Anne is leading on this, is we have some very long-term experimental sites where the scorecard approach is being tested, and also then the yields of the crops are being monitored. So hopefully we will be able to look in time as we get more data as to how these link up, and whether the scorecard for the soil health is actually then being translated into something that can be seen above ground. And I think, you know, that would be something that as we go along the program, you know, we'll get more information on that.
Yeah.
Are we happy that these green, amber and red are consistent for all crop types? I mean, one would assume that is the case, but are we happy that regardless of what crop we're growing, the indicator, the green are all the same, need to be the same? Or do we need to, are there any variations for different crop types?
I don't know that it would necessarily be the crop type. I'm thinking soil texture is probably one that is coming up as being where we might need to look a little bit more around these benchmarks. So for example, with the worms, Anne showed you that we had different threshold values for arable cropping and for grassland, because we would expect to find more earthworms in the grassland. So we have a slightly different threshold for that particular indicator. But as Anne also mentioned previously, a sandy soil, a light soil, has very few worms in if there's not much organic matter, and because sandy soils can't hold on to organic matter as well as a clay soil, the worm numbers naturally will be lower. So what we're thinking now is perhaps for the earthworms, do we need to separately benchmark for soil type? Now that's something, you know, that we're considering as part of the research program as we're developing these benchmarks, and Anne's noted on that slide they are subject to review.
I was going to point that out.
But I would say for crop type, I mean, certainly, you know, we have very well established nutrient management guide with all the indices for, you know, for the major nutrients that are listed there. So we have got that information, particularly for those crops that are going in the ground. So whilst you might do, you know, there's the soil health scorecard and look at the nutrients from that particular sample, you can then interpret it knowing what your cropping is going to be and how that fits in with requirements. And I think one of the key points to bring into this as well is individuals' knowledge and experience is really key in interpreting any scorecard approach like this. You know, if you get the results and here are your color-coded options, you know, really the individual who's farming or managing that land is best placed to be able to interpret it. And you know, the fact that we have low earthworms, well, perhaps, you know, we've just had a very you know, a root crop in the ground not so long ago, and the earthworm population hasn't recovered. So it's definitely bringing in that farmer experience and knowledge, We have a research case study actually that's available on the Great Soils website. So within this partnership, we have 8 different farmer groups around the country who are trialing this approach and feeding back on it. We have a case study that indicates what people are finding, and actually it's different systems: grassland, vegetables, arable, and how to interpret it. But I think it's definitely that personal knowledge of your cropping and your rotation that plays into it as well.
Perfect. Thanks very much, guys, and thanks very much to everybody. So resources wise, as you can see now, moving to the slides. So the AHDB website is a Great Soils project. As you can see, everything's available on the website there, and we do have the handouts down in this bottom corner here. So if you want to see more of that, please feel free to click the link and it should download onto your computer. So Strategic Farm Week 2020, we're coming towards the end of it, still a fair bit to go, so please do take part in the webinars. They've been fantastic. Do listen to the podcast special that was on yesterday. That's on the website and on YouTube as well. And do download the resources. We're trying to put as much of the topical information in there as we can. So still to come on Strategic Farm Week, we've got this evening. So we've sort of done quite a bit this morning and in this lunchtime session. Hope everyone's managed the lunch as well. So this evening is just really a bit about mold draining and soil loosening and the technical detail alongside that as to how to go about it. So that's on. And then tomorrow we've got Martin Grantley-Smith who's going to be summing up the week for us as well. So do please go and watch a few of the videos that are there. There's a lot of effort going into them there, and I'll point out the Scottish Strategic one is particularly good to watch. So just a quick reminder that this has been recorded, so it will be going out on YouTube. There is a survey that will pop up as you close the window, so please do fill that in with your feedback, whether it's good, bad, or indifferent. And if you want us to look at other directions, I think the bits I'm picking up that we do need to do a lot more research into organic manure application. There seems to be a lot of questions on that and a lot of further knowledge exchange needed. So please feel free to get in touch with me if you need to. I'll try and answer as best as we can and as factually as I can, which I'm not famed for. So, but thanks very much for joining us, and we'll hopefully see you this evening. Okay.